Hello everyone, this is Mr. Baker here. Welcome back to day 2 of AP Statistics here, analyzing categorical data. You'll notice in the textbook that section 1.1 is all about categorical data, the types of graphs used to depict those. The most common ones are the bar graph, the pie charts, and the segmented bar graphs. We'll talk a little bit more about the segmented bar graphs today. But that's what 1.1 is all about, just categorical data. We're going to finish it up today, and we'll keep on moving on here. So what you have right here is a two-way table. I know that's kind of part of your notes. What is a two-way table? But a two-way table kind of describes the distribution of two categorical variables. All right, that's really what it is. It's the distribution of two categorical variables. In other words, gender, you're male or female, and then your opinion, what are your chances of getting rich, kind of thing. All right, so it's a distribution of two categorical variables, gender and opinion. Marginal distribution, if you want to, kind of sounds like Mr. Baker, what are you talking about? It's in the margins, in other words, it's the totals of one of the categorical variables. Okay, so if you're looking at, if I said what's the marginal distribution of gender, you're looking at these totals down here in the margins. Like, in other words, this would be the totals of just that one categorical variable. If I said, what's the marginal distributions of opinions, well, it'd be all of these totals over here, because these are the totals in each of those, opinions right there in those groups. So, marginal distribution is just in the margins, and you're looking at the totals, and you often relate that to the table total, which is that bottom, square right there. So you'll kind of see how we use it here in just a minute. Use the data in the two-way table to calculate the marginal distribution of opinions. So because they said opinions, we're just going to look at the opinion totals, and we're going to put that over the table total, because they want the percentages. In other words, what percentage of people felt they have no chance of getting rich? Well, that'd be 194 out of the 4826. And I'll calculate these percentages here in just a second when I pull out the calculator. Then you just go down the list. Some chance. Well, some chance would it be the 712 over 4826. So 712, 4826. I'll do that percentage in a minute. 50-50. That would be the 1416 over the 4826. And then good chance 1421 over the 4826. And then we'll do the last one right here, almost certain. That's the 1083 over the 4826. So if I was going to calculate those percentages real fast, pulling up the old handy-dandy calculator right here. 194 divided by 4826. That percentage would be 4.02%. All right. Do the next one, 712. All right. 712 would be 14.8. Let's go 14.8 right there. 14.8%. 50-50. .34%, good chance. 29.4, kind of run out of room right there. 29.4%, and then you have the 1083 divided by 4826, and that's going to be 22.4. Good. All right. So those are the marginal distributions in percents, based upon the opinion. In other words, 4% of the people surveyed, think there's no chance of being rich. While you have a pretty good selection here, 29 and 24, almost, more than half think that there's a good chance or almost certain that they're going to be rich, which is kind of interesting. So make a graph to display the marginal distribution. Describe what you see. Are there any relationships? All right, so we're going to use a bar graph again. And, this is really based upon your opinion. All right. And then over here, you're going to have percents. Okay. So down here, we'll kind of do the same thing. You have the no chance, no chance. You have some chance. You have a 50-50. Good chance. And almost certain. Looks like the highest one that goes up to is like 29%. So we'll go up by tens again. Percent, 10, 20, and 30. And so if I'm just making this graph right here, no chance is at 4%, so that's pretty low. Some chance is at 14. 50-50. Good chance, same thing basically. And almost certain. All right, so describe what you see. Are there any relationships? It's really just taken, you could probably already answer this kind of question, describe what you see. Are there any relationships just by looking at these percentages up here? But sometimes, sometimes they'll just give you the graph and they'll ask you to describe what you see. These are bullet points for me because I'm kind of running out of room here. But, if this was an AP exam and they said describe what you see, you would just need to say, this no chance, had the smallest percentage. No chance was the smallest, percentage where you had more than half, you could say, when you do more than half, think that there is a good chance or almost certain of getting rich. Because when you add those two up, 29 and 22%, more than half of people think there's a good chance or almost certain that you're getting rich. Just pulling something from the table. It would be good if you could almost touch all of them. I left these two out right here. I guess one of the last bullet points would say is that, 50-50 and good chance are similar, in percentages. So there we go. I touched all of them, basically, except for some opinion. But it'll be all right. So just writing a few sentences about the graph, describing what you see. I think it's pretty self-explanatory. I think everyone here can do that with ease, and they feel pretty good about it. What is a conditional distribution? How do we know which variable to condition on? I'll answer that second question first. Read the question. Okay, R, T, F, Q. All right, read the full question. That's what the F stands for. Okay, read the full question. What is conditional distribution? Really, you're just looking at one of the categories. Or I should say, within one column. That's really the big thing, all right? Within one column. Conditional distribution for all of those probability lovers out there, because I know everyone loves probability. Conditional distribution is really that whole given statement, that whole, probability of A given B kind of thing. When you see that given is kind of like the condition, given that you're female, what's the probability that you, how do you feel about getting rich? So that's where conditional kind of comes into play. It's all about the given. All right? So, calculate the conditional distribution of opinion among young men and women based on the survey data. Can we conclude that young men and women differ in their opinions about likelihoods of future wealth? All right, so calculate the conditional distribution of opinion among young men and women. In other words, we need to compare men to women. Now, what I get a lot of sometimes at the beginning is that, for example, this is what not to do, and I'll kind of write this in our notes. Like if I want to compare percentages of female, 2 percentages of males, I think there is no chance of getting rich. You don't want to do 96 over 194 for the female, and then do 98 over 194 for the males. Because, I mean, yeah, sure, if I throw my calculator up here, and you're like, okay, 98 divided by 194, this says 50.5%, My question to you would be, did really 50% of the males say that there is no chance of getting rich? Just like this is probably going to be 50% of the females saying that there's no chance of getting rich. When you look at that, you're saying, well, their opinions are the same. Not really. 50% of males did not say there's no chance of getting rich. What you need to do is the 98 out of the 2459. That's the percentage of males that said there's no chance of getting rich, while 96 divided by the 2367 is the percentage of females that say there's no chance of getting rich. That's how you're going to do this right here. We're going to work within these columns based upon gender. Okay? Don't do it this way. Don't do it left and right. Do it vertical. All right? So I'm going to X that out. That's not what you want to do. All right? So I'm going to kind of throw that up there. I'm going to use them as I'm writing this down, but calculate the conditional distributions. All right? So here we go. So let's do the females. And so we do no chance right here. That's going to be the 96 out of 2367. We'll do some chance. 426 out of 2367. Now this is where it'd be nice if we were in the classroom. I'd be having each of you do this separately. We could get the answers real fast, but, we're doing the best we can. Then you got good. And almost certain. We'll do the males. Same thing, same category. So 98, 2459, 286 out of 2459. All right. So I'm going to plug these in real fast. Then I'll know the answers. We're just going to call that 18. When you start rounding it, 18%. Bear with me here, we're almost there. Halfway. Alright, doing the males. Good times, right? Good times, great oldies. Here we go. Almost there. And the last one, 597 divided by 2459. There you go. Alright, so there's the conditional distributions of opinion among young men and women. Based on the survey data, can we conclude that young men and women differ in their opinions about the likelihoods of future wealth? Well, most definitely. I mean, you could say, well, according to the no chance, they are basically the same. You could go down in each category. These are similar when it comes to no chance. I'll just kind of do bullet points out here for you. So similar in the no chance. It looks like, when it comes to similar no chance, they're also similar in the 50-50 and the good chance when it comes to percentages, right? But what you'll notice is that, if you add these two together, I mean, right now this is 48%, when you add the good chance and almost certain. This right here is 54%. So, you could say more males think that there is a good, to almost certain chance of getting rich. A higher percentage, I should say, not more males, but a higher percentage of males think that there is a good to almost certain chance of getting rich. Okay, just picking anything that you want to out of these. If you want to come back and say, there's 7% more females think that there is some chance of getting rich than males. Whatever you want to do, just based on the survey, can you conclude that young men and women differ? Yes, you can. All right. So there's the conditional distributions. Let's go ahead and flip this over, and we'll get to the second page of our notes. All right. What is a segmented bar graph? Why are they good to use? Well, a segmented bar graph is basically a stacked bar graph. Okay, and that's where y'all have seen these before. They kind of look like Band-Aids. They have the whole, they usually break them up into different categories. And, on a test, they'll have that, and then the dots, and then, who knows, they'll have hearts in this one. It doesn't really matter. But it's a stacked bar graph. Why are they good to use? It's like a pie chart bar graph. In other words, the percentages add to 100. Okay, the percentages add to 100. And why is that good? Well, you can make comparisons to the whole. Now, when have we used that phrase before? When you make comparisons to the whole, that was all about a relative frequency. And relative frequency is the same thing. It's using all the percentages, comparing them to the whole. Okay? What does it mean for two variables to have an association? How can you tell by looking at a graph? Well, if knowing the value of one variable helps you predict the other. Then there's an association. Okay? Knowing the value of one variable helps you predict the other. Then there's an association. How can you tell by looking at a graph? Well, I think you'll see here in just a minute, but one that I like to use, as well. Like if you had we'll use a segmented bar graph, right? If the two segmented bar graphs were looking like this, right, and they, we'll say this one's males and this one's females right here, and this is the percentage of people that like pepperoni, and this is the percentage of people that like cheese, CP, whatever. If this is what my bar graph looked like, for both males and females, and they were maybe asked their favorite pizza. Well, either way you look at it, if you like pepperoni, do you automatically know that you're male or female? Well, no, because the percentages are the same. Just like if you're male, do you automatically know that more males prefer pepperoni? No, because looks like pepperoni and cheese are the same. So when you're looking at a segmented bar graph or other bar graphs, if the bars are the same, there's really no association because you can't tell which one is which, right? So if I know that you're female, can I say that more females, you're more likely to like cheese pizza? Well, no, because again, cheese and pepperoni are the same. It looks like. So that's how you would tell if there's no association. But once you start to have some differences like this, or something like that, when this is pepperoni and cheese, that's when you know there's association for like males and females. Like, in other words, if you're a male, you probably like pepperoni, right? If you're a female, you probably like cheese, that kind of thing. That's an association. This is not an association. So no for this one, yes for this one. Let's do this last example. Cell phones. The Pew Research Center asked a random sample of 2024 adult cell phone owners from the United States which type of cell phone they own, iPhone, Android, or other. Here are the results broken down by the age category. There you go. Based on the cell phone data, is there evidence of a difference in the distribution of cell phone ownership for the three age groups? Right? They want to compare the distribution of cell phone ownership within the three age groups. So, which way do we need to go? Do I need to do these percentages? 169 over 467, 171 over this, 127 over that? Or do I, is that going to compare the cell phone ownership within the three age groups for that? Or am I going to do the 169 over 517, 214 over this one, 134 over this one? Hopefully you see that it's the second one. I want to compare the percentage of people that own iPhones in this category to the Androids in this category to the other cell phones in this category. So we're going to go vertical on this one, right? Just kind of reading the question, kind of understanding what they're wanting. So let's go ahead and just do that real fast. So 18 to 34, let's do the iPhone. We'll kind of hammer these out real quick. Android and other. So 169, 517, 214, 134, and no, 214 and 517. I'm getting ahead of myself. I apologize. And then you got 134 out of the 517. Let's go ahead and do the next age category real quick. All right. That's for that category. And then you got 55 plus. All right, so I'll slide that up there so you can see all that. Thank you. All right, so we're doing this within each age category, doing the conditional distribution, even though they don't say conditional distribution, but that's what they're asking. Is there evidence of a difference in the distribution of ownership within the three age groups? So, real quick, I'll hammer these out with the calculator. Okay, so 169 divided by 517. That's 32.7. We'll round to the tenths place on this one. People always ask me, Ms. Brady, what do you round to? Well, I would for sure have at least one decimal. You know what I mean? To the tenths place. So, all right. Got it. And do the next one. And here we go. All right. Now, you can comment on this just by looking at the percentages. But I do want to just take a moment to maybe do like one of these graphs so you can see it. Typically when you make bar graphs, you keep the bars separate because once they start touching, you get into the histograms, and histograms are all about categorical quantitative data. Histograms are all about quantitative data. But, like I said earlier, we are only looking at categorical data. So sometimes bar graphs can touch, especially when you're doing conditional distributions. So, like if I just wanted to show you one graph right here, one little, we might do two, you never know. So the 18 to 34 age range right here, right? And we'll do the percentages over here, percentage over here. You can make 3 bars that touch each other. Like in other words, we'll go by tens, I guess. 10, 20, 30, 40, 50, 60, 70, right? iPhones, 32%, 33%. So I draw iPhones, and we'll make this iPhone, right? Let's do Android. Android is at 41. Notice I'm having these bars touch now right here. Okay, you can have bar graphs touching as long as you're doing conditional distribution. 25% for the next one, so that would be your other. So we could go through and make some graphs based upon the age groups like this, 35 through 54. They might ask you to. You never know. So, we might as well just go ahead and do it. This one's 26% for iPhone. We'll do 29 for the next one, so it's just a little bit higher. 43 for that one. All right, so again, iPhone, Android, and other. And then the last age group, 55 plus. Y'all are doing great. Hanging in there. Stay with me. 14. This one would be 11, so a little bit smaller. And then the last one would be 73. So first of all, what can you tell about probably older people? First of all, they like their flip phones. They don't like these iPhones and Androids. Technology with older people is hard to do. But you could say something like that. Older people like their flip phones. They don't have very many smartphones. Within the younger age group, it looks like Android is the most popular. And as you get older, it looks like flip phones become more popular. Other was the highest category for that one. So, just throwing that out there. Little graph for you to see. Oh, I got to properly label. This down here should be age group. I apologize. You got to get full points on the AP exam. But got things labeled right there. We commented on that, justifying your answer. That's basically justifying your answer with work and percentages and or a graph. But we're good to go right there. Here's your homework for day 2. And thanks for joining me today. I hope you enjoyed it. We will see you again.